Asoba is going to speak to us about data optimization in the energy sector. Fresh from the USA, so welcome, Shinda.
Thank you. Good afternoon, everybody. It's good to talk to you, and appreciate being invited to this opportunity to speak to you. So I want to talk a little bit about Asoba, AI for resilient infrastructure. Should we get this? The Google one? There we go. Yeah, so I want to talk first about our mission, which is to leverage decision and predictive artificial intelligence to drive critical energy infrastructure. And the mission itself is driven by the fact that there's such a tremendous opportunity here in South Africa for the deployment of renewable and distributed energy resources. Something around the tune of 12 gigawatts have been deployed over the last 3 to 4 years. And while that in itself has been amazing and has positioned the country competitive globally in terms of the deployment of these resources, I think one of the things that is often forgotten is that simply deploying these resources is not happily ever after. That you still have to manage and ensure that these plants are running operationally for the lifetime of the asset, which is anywhere from 20 to 30 years. And that has been one of the largest challenges that we've seen when it comes to solar and it comes to distributed energy resources. We see, for example, 800,000 Rand per megawatt per year in terms of cost as a result of maintenance issues that comes up. We see, for example, anywhere from 3 to 5 days that it takes typically from a median perspective to address outages and issues that happen on site. In other words, the plant is not running at all for several days while the asset manager figures out what to do and how to deploy the resources, right? So there are a number of problems that happen across this value chain of operations that prevent the maximum amount of uptime and therefore the maximum amount of value that's being driven. And a lot of the problem that comes from this is that we're dealing essentially with a new technology but using old tools to manage that technology. And what I mean by that is it's almost less of a hard equipment problem, and it almost entirely is a data problem and a data governance problem. In other words, we have components like inverters that are providing hundreds of megabytes of data per day that give us information about what is happening at the plant, what is happening outside in the weather, what is happening in terms of consumption. And we need to be able to effectively leverage that information to drive decisions and to therefore ensure boots on the ground where they need to be, when they need to be in a timely fashion. And one of the biggest challenges that is facing asset managers today is that they simply don't have the tools to do this at scale. And especially when we talk about the scale of 12 gigawatts worth of assets, right? This is a pretty substantial problem that affects the entire country. And this is not just a South Africa exclusive problem. This is a problem with asset operators across the world. We have a number of different manufacturers, Huawei, SolarEdge, you name them, that all have their own individual platforms that are providing data from these inverters. And so from an asset operator's perspective or an asset manager's perspective, you have to figure out how to manage and combine all of that information into one place in order to be able to then figure out and run forecasting models and run decision models to tell you what to do, when to do that. And so typically what's happening right now is that people are running all of this off of static Excel spreadsheets, introducing a lot of error, and as I pointed out before, you end up having situations in which sometimes weeks, sometimes it's the client that complains to the asset manager saying, hey, why am I not getting power? That determines when these issues are even discovered many times. So the core solution that we're driving is one in which we centralize the management of all of that data and management of all that information. So the phase one is we connect directly to each of these different inverter portals, whether it's Huawei, SolarEdge, you name it, and provide our own production platform that streams everything back to the asset manager, that allows them to have a single operational control center, if you will, that will then pop up, provide predictions, tell them in very clear terms what is the actual probability of failure, when is the likelihood that this is going to need to be fixed, what is the energy at risk, which is the total cost to you, the asset manager or the asset owner, of the downtime that's associated with making this fix. So one of the key things that we're introducing, and so as I mentioned, phase one is the centralized platform that connects directly with all of the different API providers of these inverters. But phase two is in fact where we deploy microcomputers, so think Raspberry Pis among other different brands, directly on site, so that we are no longer having to push anything to the cloud. That provides independence from, at this point, predominantly foreign-based cloud providers, which I'll talk in a little bit about data sovereignty, but that's a critical issue given the importance of energy resources and the importance from a national security perspective of the specific kinds of data that's running on our platform. So I'll get to that in a moment, but I first want to highlight just the scope of the market opportunity in this space. So there's a $3 billion total market opportunity from the standpoint of energy trade that's occurring. From the serviceable market that we're seeing is about 630 million, and sort of the immediately accessible market from that is about 250 million in USD terms. So we can move very quickly, even in phase one, to capture a large portion of this market. And again, a large part of that is driven by the fact that there are significant regulatory tailwinds. So there have been numerous conversations at this, the G20 and B20, talking really deeply about how South Africa is in a really interesting market leadership position, right? I'm coming from the United States, and you'd think that there would be a lot of investment in this space there. But in fact, the economics aren't supportive of renewable energy pretty much across the board without substantial subsidies. So South Africa is dramatically different, right? This represents a very profitable market for independent power producers and for utility companies. And we're representing an opportunity for them to comply with what we see coming in with the wholesale energy market, where it has increasingly high and stringent reporting requirements around forecasting, as well as uptime requirements. And these are things that you cannot rely on the traditional tools in order to do that. You definitely need advanced analytics, you definitely need artificial intelligence to be able to provide the predictions and to be able to provide the decision support in order to fulfill the contracts that are required to participate in this very lucrative market. Now, the other thing that this also suggests, and I mentioned this before when I talked about data sovereignty, is that it does require a level of, I'll say, national level coordination across this. I don't think this is something, and I'm saying this even as a vendor myself, but I don't think that this is something that should be driven by sort of an iterative private market process. I think we've seen the promise. I mean, we have successful proofs of concept. We have successful commercial deployments both in South Africa as well as the United States. But I do think that this is something that from an infrastructure perspective, from a data sovereignty perspective, that this is something that institutional stakeholders at the national level in South Africa do also need to take a leadership role within. We do see, for example, the opportunities for deploying artificial intelligence at the local level to capture this data that we're currently capturing from these distributed energy resources. And there are many different use cases and purposes from an intelligence perspective, from a national security perspective, from a grid management perspective, from the ESCOM perspective, to also capture the information that we're able to bubble up. Not just the raw data, but also the insights that we're generating, the dispatch decisions that we're generating from the assets that we're managing. I think all of this needs to be coordinated and to ensure optimal grid capability and grid functioning, because as we're seeing, when you have 12 gigawatts across tens of thousands of power producers coming online, there's a lot of traffic coordination that has to happen for us to have a successful functioning grid. And I think also what's important in this is, there are significant requirements from a compute perspective to support this artificial intelligence. And I know that there's been a lot of conversation around the development of data centers and the development of capacity and infrastructure to support that. But one thing that I will leave everybody here with is there's about a 10x higher cost to centralized data centers when compared with the distributed approach that we've been implementing, where we have, like I said, these really low cost computing devices like Raspberry Pis or these NVIDIA Jetson Aura Nanos that have small scale GPUs that are attached, but cost anywhere from $200 to $400 MSRP USD that you can deploy, and you can still train models, you can still run models, you can still run inference the same way that you would if you were deploying on AWS, but with a dramatically lower cost, both from the perspective of the pollution that comes from data centers, but also from the pure infrastructure cost that's involved with this. And I think this is, again, a really good opportunity from a South African perspective to get back on the board when it comes to this, I'll call it AI Cold War that we're seeing, where you see these trillion-dollar investments in China and the United States to build out these capabilities. But in fact, you don't need to spend that level of money to get the same kind of capability when you can develop in a very distributed fashion. And we've seen similar paradigms when you talk about the computing revolution here, where we completely skipped the desktop and went straight from nothing to mobile computing. And we can do the same thing from an AI deployment perspective. So from a traction perspective, again, we both have the private market participation. We have a partner, LTM Energy, that is helping us enter the market, providing a white labeling relationship and licensing where we're able to get assets under management that way. And we're also working with Sustainable Energy Africa to build out an energy oracle that will allow just developers, IPPs, you name it, to be able to essentially in ChatGPT style go onto the small scale embedded generation website, ask questions about regulatory issues, and be able to get direct answers through our LLM to help them identify their query. And again, all this information can then be shared at the national level with Eskom and other utilities to better understand what the actual needs are from a commercial deployment perspective of these assets. And again, we can talk more about revenue model offside. But again, from a funding perspective, we're in the process of closing our first pre-seed round of $1 million USD. We've raised about $580,000 of that from investors both here in South Africa as well as the United States. And our leadership team, myself, CEO, as well as my co-founder Gertie, our COO, both here in person. So happy to talk to anybody here about these issues, both from a deployment of assets perspective, as well as sort of the broader high-level discussions around AI and data sovereignty. But thank you everybody for your time, and I'm excited to be part of this program.
Fantastic. I see